learning experience, isn't it? After how many years of doing these live, producing a virtual one, shall we say, is fun. So, well, another picture that we can showcase here from one of our members, John Williams. It's the Heart Nebula. And I think it's pretty easy to see from this. It is shaped like a heart. And if you look right in the center of the photograph, there's a bright area, bright cluster of stars. And it's the energy radiating out from that bright cluster of stars that's energizing the hydrogen and making it glow its pretty colors. And that's where that comes from. So again, very, very good pictures that we've got coming from our group. It's more than just looking through the scope. Sometimes it's taking fantastic pictures. And in terms of looking through a scope, well, you don't always have to just look through and look optically, but sometimes you want to look through radio frequencies or other wavelengths. And that's what our next speaker will be talking about. Tom Auchter wants to talk about the Arecibo telescope and some of the great things it's done over the years, and of course, even its recent demise. So Tom, I'll pass it over to you.
Okay, thanks, Wally. Let's get this up. Okay, so good evening, everyone. I'm Tom Auchter, a member of the Northwest Suburban Astronomers, and tonight I'm going to talk about Arecibo, which was the largest radio telescope for over 5 decades. In fact, until it collapsed last year, it was not only the largest, it was also the largest and most powerful telescope capable of transmitting. So I want to share a little bit about some of its history tonight, a few of its discoveries, and then also its great loss to the scientific community in large. So to begin with, I'd like to share a little dramatic footage that was recorded last year on December 1st at about 8 a.m. local time of the collapse of the telescope. This was from a camera in the control room. You can see the platform crashing down as the cable's let loose. Tower 4 starts toppling over, and what's coming down the hill here is the top of Tower 12. They also had a drone up monitoring where the cable was the weakest, where one of the main cables had snapped. And in this video, you can see this cable starting to fray, strands going, and then complete failure. The camera pans over again on the drone to see the collapsing telescope. You can see the top of Tower 12 cascading down the hill there, which you saw in the other video. So I was quite stunned when I saw this on December 1st, when this information came in about the collapse of the observatory. So the aftermath, you can see, was complete destruction of the telescope, which turned out to be a great loss to the scientific community. In October of 2018, my wife and I had the opportunity to visit Arecibo. And at that time, of course, it was still operational. So it was a very fortunate visit, knowing what we know now. This elevated view of the observatory gives a nice overview and just shows the immense size of the telescope. The dish there is over 3 football fields across. The towers extend up into the sky, a football field. So it's just a massive instrument when you see this. Also, we'll talk about this a little bit later, but notice that the dish is kind of discolored. The other thing you get a good view of in this picture is the surrounding region and the geography. So the telescope is in what's known as a karst region, where there is natural sinkholes, which is very advantageous to building the large dish. On the walk up to the observatory, there's a nice scale model of a solar system. Maybe some of you saw Edith's presentation earlier tonight on making a scale model. I'm standing next to Mercury at the moment, and Edith, if you can make it out here in the distance, is standing next to Earth. And the scale model goes up the walk as you head up to the observatory. Each of the planets has a display like this. This one is particular one, as you can see, is for Mars. And it gives information such as the size, the mass, the orbital period, its day, and it's all relative to the Earth. So it compares it to, to us. The visitor center is quite beautiful in the surroundings, and it has excellent exhibits and displays. We'll show you some of those. Coming up to the visitor center, you kind of get the first view of the scale of this instrument. When you see Tower 12 here, reaching up to the sky behind the visitor center, and that's the one that you saw crashing down the hill in the collapse. So you start getting a sense of this is an enormous thing that you're going to see. Inside, as you get in, you're treated to kind of an overview map of where Arecibo is located. It gives you an orientation of, where it is on Earth in the solar system. As we go out into our galaxy, where in the Milky Way it's located, our Milky Way in the local group and in the universe. So that's nice display to kind of ground you of where you're located. In the lower part of that, and we'll look in that a little bit more detail, is a view of the electromagnetic spectrum, showing going from the short wavelengths on the left, high energy, such as gamma rays, X-rays, down to the optical wavelengths, which of course are where we see and we're all familiar with, then through infrared, microwave, and finally down to the long wavelengths of radio. And that's where Arecibo operates in. It's important to, as astronomers, to observe at all these different wavelengths because it increases and expands the knowledge that we obtain of and understanding of the universe. Inside the visitor center, there's a nice display showing a model of the telescope so you can get familiar with the different components of it. You're also able to see how the telescope moves, and then stretched above that are the planets of the solar system. Also, did you know Arecibo was used as a movie prop? You may have seen it in Contact, featured in Contact, and also in the 007 James Bond movie GoldenEye. So they actually use the telescope as a prop in those movies. So this was an interesting thing that the telescope did back in 1974. I believe. Trying to remember the date here. My mind's gone blank for, yes, 1974. And it beamed a message to this object, which is a globular cluster. It's known as M13, and it's in the constellation Hercules. This object contains over 300,000 stars. So they thought it would be a good place to send out a message to see if it could communicate it with anybody that might be out there. Now, one of the difficulties here is this object is 22,000 light years away from us. So it's going to take that message 22,000 years to get there. And if you remember, a light year is how far light travels in 1 year. So during that time, light would travel approximately 6 trillion miles. Now, when the message gets there, and assuming that there is a technologically advanced civilization there that can decode it and communicate back to us, so it's going to take another 22,000 years to get back to us. So you can see that communication on the scale of our galaxy is very problematic. This message was developed by Carl Sagan and Frank Drake, pictured here. Frank Drake is the author of, or is known for, what the Drake equation, which postulates how many technologically advanced civilizations may exist at the same time that could communicate with each other. Now, the message, of course, was sent out as a digital stream, but it decoded into this picture. And basically what's in here are the digits, followed by atoms that are essential for life, followed by the molecules that make up DNA, and of course the double helix, a human, a representation of human, a model of our solar system, which yes, does also include Pluto at the time, and then the Arecibo telescope. And that's the message that was sent out back then, and is still traveling and hasn't gotten actually very far yet. So one of the things Arecibo did a lot of was planetary, for over 5 decades, was planetary observations. Arecibo was first to measure the rotations of both Mercury and Venus, and actually discovered that Mercury wasn't unlike our moon, or was not tidally locked to the sun. So it did not always present the same face to the sun as it orbited around it. It scrutinized Saturn's rings, mapped the surface of the moon, and also in 1990 discovered the first exoplanet that we've talked about. So that planet happened to be that it discovered was orbiting a pulsar. This image is of Venus and was taken in 2012. You may not realize it, but Arecibo was used extensively in atmospheric science to measure the atmospheric composition, temperature, and densities in order to better understand the physical processes that are going on there. It's also studied plasma physics in the ionosphere of the atmosphere. So a lot of research was done in that area. Probably one of the big things that it was known for is in 1974, Joseph Taylor and Russell Hulse measured the changing orbits of a pair of neutron stars. And the theory of relativity indicates that as those stars orbit around each other, that they'll give off gravitational waves, and then the energy carried away by those waves will cause the star's orbits to shrink. And this is what they observed. So for that, it was awarded the Nobel Prize of Physics in 1993 for indirectly confirming the existence of gravitational waves. It was pretty cool to see an actual Nobel Prize. Although Arecibo is no longer, or was no longer, the largest radio telescope, once FAST telescope became operational in China last year, it continued, as I said, to be the largest radio telescope that was capable of transmitting. And over the past decade, it had been heavily used for expanding the observing of near-Earth asteroids, monitoring for close approaches. So here's an example of a observation of a near-Earth asteroid. This particular one is known as 2017 YE5. And as you can see, it's actually has two components that are in orbit around each other. And with the radio telescope, they were able to determine the orbit of those two around each other. They were able to determine the orbit of the overall asteroid and the size and shape of the objects. Here's another one, 2014 SR339. And again, you can see, as Edith mentioned earlier when she was talking about the asteroid belt, this thing has kind of a potato shape. It's about 7.5 meters, or excuse me, it's about, I was looking at the wrong thing there. It's about 1.5 kilometers in size, and it has about a 9-hour rotation of the body spinning when it's spinning around. On the tour, we saw many historical photos, which were quite interesting to see as the observatory was constructed. So here's a picture back from 1960 when construction was going to begin of an overhead view. So again, you can see this karst region where the sinkhole is, and that would form nicely for the dish of the telescope. William Gordon is known as the father of the Arecibo telescope and was responsible for designing it. And again, he was interested in the study of the properties of the upper atmosphere. And he felt that he could use a radar system to measure the density and temperature and other properties in our upper atmosphere. The triangle support is used to hold the various antennas and transmitters of the telescope. Here you see a photo of it had finished construction and they were hoisting it up between the towers. And then here you got guys that obviously have nerves of steel. They're working over 500 feet above the ground on the supports up there, connecting the rotating ring below it. And here you can see that that's been completed out there now, and they have the walkway out to it. They just need to add a little bit of protection on the side of that, but I don't think you would get me walking out that up there. And then finally, in August of 1963, the observatory was completed. So many improvements since 63, many improvements have been made to the observatory over the decades. In 1974 specifically, the wire mesh of the dish that you saw in the last photo, that historical photo, were replaced with these aluminum panels, almost 4,000 of them. And they're 6 by 3 foot in size, and then each panel is individually adjusted to maintain a precise spherical shape for the dish. The total weight of the dish after this upgrade was 300 tons. So how would you like to walk around on the dish on these funny looking little shoes? So anytime anybody had to be on the dish to work on it or make a repair or something like that, they needed to wear these to distribute the person's weight so there wouldn't be any, deforming of the dish out of the precise spherical surface. So pictures, when we were standing outside the visitor center on the observation deck looking at this, taking this picture, they just don't give you the sense of the scale of this thing. You can't get the impression of how large this instrument is by looking at a picture. The structure in the center, which we'll talk about a little bit more, that has the transmitters and receivers, the observing platform there, that weighs approximately 1,000 tons. The other thing to note in here is the dish compared to that first photograph where it looked kind of grimy. Here it looks nice and white. So since its existence, or it built in '63, the dish had never been cleaned, not once. After Hurricane Maria, when the dish was underwater, when they came in and did some repairs and stuff from that hurricane, they cleaned the dish. So now it has, when we were there, this nice, clean looking surface. So again, here's the center area with the triangular support, what's known as the azimuth arm that allows you to rotate the receivers and transmitters. And also you can move them along that arm to observe different parts of the sky. In 1997, that dome on the right, known as a Gregorian reflector system, was an upgrade to the telescope, along with the receivers that were in that dome. And that allowed it to operate in a greatly expanded range of frequencies, a 2,000% increase beyond its original design when it started in '63. Then also on the left, what used to be there was a line feed, and it used to be 96 feet long. That hadn't been repaired yet when we were there, but that was broken off in Hurricane Maria and had crashed through the dish and made a hole when it broke off, but that was repaired. Here's a section of one of the cables, the things that caused all the heartache. There's a total of 39 cables that support that platform. The combined cable length, if you lined all those up, is about 4 miles. And each cable, each of those 39 cables weighs 10 tons. So leading up to the collapse, 3 cables broke. The first one actually was a support cable, then a main cable. One of these broke, and the final cable broke, and the telescope collapsed. Another upgrade, this 12-meter dish was added in 2010, and that allowed the combination of signals from other radio telescopes from different continents or even spacecraft with Arecibo. And that's a technique that's called very long baseline interferometry to improve the resolution of the telescope. On the transmitting end, the radar end, the interesting part of Arecibo, here's an example of what are known as klystron tubes, which are used as the amplifiers for the high radio frequency of the 4. Arecibo has 4 different radar transmitters. And the most powerful can transmit at up to 20 terawatts of power. Just as a comparison, a typical FM radio station is 100 kilowatts. That's what the FCC limit is now. There are some grandfathered in ones that might be around a half a megawatt. And I think when I was searching around, there might be a couple stations in the world that are in the 1 to 2 megawatt range. So you can see quite a bit of difference when you're talking kilowatts to 1 or 2 megawatts to 20 terawatts. And then finally, I shouldn't say finally, but the collapse that we saw earlier was from a camera in the control room. So while we were there, we were visiting the control room. And since Arecibo is a radio telescope, it can work day and night. It doesn't have to worry as an optical nighttime only to be able to use a telescope. So there was an active observing run going on, and we were talking with the astronomers. And in fact, it was using the VBLI interferometry. It was connected with other telescopes in the world at that time. And it was observing a supernova along with those other telescopes in another galaxy. Unfortunately, because the run was occurring, the instrument was active when we were there, we weren't allowed to go down and tour around or underneath the dish. This is the tape vault at Arecibo, and Arecibo has recorded a treasure trove of observations, which will inform scientists' work for many years to come. Just to give you an idea, the observatory has produced over 3,500 publication papers. It's generated over 400 master and doctoral theses. But unfortunately, no, there weren't any tapes in there, or so they told us, of any little green men. So when we looked out at the telescope from the outside of the control room in 2018, Arecibo appeared to have a very bright future with many planned upgrades to increase the capabilities of the telescope. Unfortunately, that all came crashing down in December of last year. So there are already proposals for rebuilding under review, but will it happen? And if so, how long will it take? We don't know at this time, but we'll have to stay tuned to see what happens. If you're interested in learning more, here's some links, and these will also be published, as Wally had mentioned. So there's a link for learning more about Arecibo, the electromagnetic spectrum, understanding more about that, and then also observing at various other wavelengths in the electromagnetic spectrum. For example, the Chandra X-ray Observatory, the Hubble Space Telescope, of course, in optical, and the Spitzer Space Telescope in infrared. So if anybody has any questions.
Anybody have any questions for Tom?
I have a question. You talked about the aluminum plates replacing the original panels.
Well, it wasn't so much panels. It was more of a, think of it as a wire mesh that was strung around the thing.
And I forget what you had said. There's 300 tons or 300.
Yeah, so the weight of those 4,000 or almost 4,000 panels that they installed is approximately 300 tons.
So what was the weight of the scope prior to that replacement? Do you know?
That's a good question. I don't think I know that or saw that anywhere in the looking. They didn't bring that up when we toured at all.
I would just think it'd be lighter because the newer ones were aluminum. So I would.
Yeah, but it's much more solid. So with those panels in there, it was all upgrades to allow the telescope to get to higher and higher frequencies.
Thanks, Tom.
Field, I see there's a question about field of view. I don't know if I have what the exact field of view of the telescope is. I know it could,
It's narrow.
yeah, no, it's narrow. It observes roughly over itself. I forget the declinations. I think it's something like plus 40 or something like that declination down to -1 degree as far as coverage on declination. So I don't have the actual field of view. Did the sinkholes contribute to the cable failures? Not to my knowledge. Basically, it's a tough environment. You're down in a rainforest, there's earthquakes, you have hurricanes. Probably the thing that accelerated it the most maybe was Maria. A lot of salt water was brought in. from that hurricane, and in that environment, that's not good. Now it's interesting enough, those cables do have blowers on them that actually blows air down to keep them to help keep them dry. But and of course, the other thing with all the adding of instruments, that platform became a heck of a lot heavier, but there were additional back support cables put on.
I've got a question here in my chat from Virginia. What is your occupation?
My occupation when I was working, I'm retired at the moment, but or I should say I'm retired, is I was an electrical engineer.
Another question from Russell. What are the rebuilding plans?
Well, there's some proposals out there, and I know NSF is supposed to be having, I think, a conference this summer that's going to be reviewing some of those. There's a couple different, I think there's a couple different ones where they're actually talking about some in that same area, a bunch of platforms that they can individually tilt and tip instead of a mass, a solid dish, having it composed of thousands of individual platforms. So there's a variety of different proposals out there, but again, the question is where for the cost of building another instrument, you're competing against a variety of other programs. But it is being looked at, and it is a tremendous site. And I know when you talk to the people in Puerto Rico, it's a great loss to them personally. It was one of their favorite things, and a lot of the kids visit and tour through that. I forget the numbers, and there are numerous kids that ended up going on and becoming astronomers, and then even working there from Puerto Rico.
Thanks, Tom. Those are the only questions that I've got.
Okay.
Chat.
Yeah, I have none here, Tom. Well, thank you, Tom. That was fascinating.
Yeah.
It's kind of neat to get it from the tourist perspective. Usually you're just seeing something on a PBS channel or reading something online. It's kind of neat to see how it was inside out as you toured the facility. Very interesting.
Okay.
All right, Tom, thanks again. Very interesting. I was out in Puerto Rico about 2 months after Hurricane Maria, and as we were touring different hospitals there and the damage, we drove past the road that went up to the observatory, and I so wanted to take a detour. I didn't know when I was going to be in Puerto Rico again, and now with the damage, I sure wish we would have taken a detour.
Yeah, as I said, it was very fortunate we got there when we did, and that is an interesting road that goes up there.
Yeah, it looked like it from the highway, that's for sure. Well, thanks again, Tom.
Yep.
All right, I'm going to go ahead. We'll show a last picture, and then we're going to get into Jim Kovac's presentation. This is a picture that yours truly took up at Wildcat Mountain last August. This is called the Phantom of the Opera Mask. As you can see, you get a couple of eyes and a mouth there. It's a nebula that's in the constellation Cassiopeia. This represents about 8 hours of data. 5 hours of hydrogen alpha, which is what brings out the red in the mask and some of the red there in the surrounding clouds and surrounding nebula. And then 3 hours of red, green, and blue data just to bring out the star colors in that very, very rich star field. So
You got to share it, Mike.
I was going to say, yeah, you got your.
Oh, that would help, wouldn't it?
Yeah.
I always forget to do that. Let's do this again.
Mike has to take a bow. This is his photo.
All right. Hopefully you're seeing it now.
Yes.
There we go. So again, hydrogen alpha is what's bringing out the mask features in the nebula, and then you've got some of the other red clouds here. And then again, red, green, and blue just to bring out the star colors.